Welcome to this explainer. Okay, if you've ever stared down a massive database and just kind of wondered how to extract exactly the specific pieces of information you need without drowning in thousands of rows, well, you're in the right place. Today, we're walking through a step-by-step coding tutorial on writing cleaner, far more efficient SQL queries. We're going to master taming your data using advanced limit and aliasing techniques.
So here is our roadmap for today. First, controlling output with limit. Then, advanced limit and offsets. Third, simplifying queries with aliasing. And finally, comparing aliasing syntax. Let's just jump right in.
Section 1, controlling output with limit.
Now, when you're querying massive tables, you obviously don't always want to see every single row, right? That's where limit comes in. It's a SQL command that specifies exactly how many rows are needed in your final output. You can really think of it as a sturdy dam controlling a literal flood of information. Placing this right at the end of your query guarantees you only pull what you need, like, say, just the top 3 rows. It's a super simple concept, but it is absolutely vital for performance.
So the crucial point here is how this works when we combine it with other commands. Take a look at these steps. We start by querying our employee demographics table. Then we add an order by age DESC clause, which sorts our data from the oldest employee down to the youngest. And finally, we apply limit 3. So what does this actually do? Well, it solves a very real-world HR use case. Imagine human resources needs to efficiently identify the top 3 oldest employees to prepare a new senior benefits package. By combining order by with limit, you completely bypass all those thousands of irrelevant rows and extract exactly those 3 specific individuals in just a fraction of a second.
Section 2, Advanced Limit and Offsets.
Now, when you need to target very specific rows right in the middle of your dataset, limit goes from being a simple cap to a real precision tool. Take a look at this specific syntax string, 2, 1. When writing your SQL query, you can actually pass 2 numbers into your limit clause exactly like this. But what do they actually mean when they're sitting side by side?
Breaking it down, that first number, 2, well, that's your offset. It signifies that the resultant rows shown will start at position 2. Essentially, it's telling the database to skip down. The second number, 1, means it will be showing just 1 row after that starting point. So our query skips down to the second position and outputs exactly 1 row. Now, why does this matter? Well, this is a perfect real-world technique for paginating results on a website. You know when a user clicks next page on a massive list of employees? An offset like this is running under the hood, skipping the rows they literally just saw and limiting the output to the next batch. Pretty cool, right?
Moving on to Section 3, simplifying queries with aliasing.
As our queries get a bit more complex with math and aggregations, our code can start to look, well, incredibly messy. Aliasing is our way out. It's essentially a way to change the name of a column in the output by assigning a function a specific name. So instead of writing out a clunky function like avgAge over and over, you simply assign it a clean name that also reflects beautifully in your final output table.
To use a simple analogy, think of aliasing like giving your data a nickname. Just like you might give a coworker named William the nickname Will, you're doing the exact same thing for your SQL functions. Giving a complex mathematical function a short, snappy nickname saves you typing time, drastically reduces that visual clutter on your screen, and makes your code instantly readable to anyone else who might look at it later.
Let's see this illustrated in a real-world application. First, we calculate the average age, but we nickname it using the as keyword, calling it average_age. Next, we group our data by gender. And finally, instead of typing out that entire average function all over again for our filter, we just cleanly reuse our new nickname in the having clause, having average_age greater than 40. Bam! We instantly find demographic groups with an average age older than 40. It is elegant, it's readable, and it is highly efficient.
And that brings us to Section 4, Comparing Aliasing Syntax.
In this little side-by-side syntax showdown, notice the subtle nuances. On the left, we have our function written out with the as keyword, avgAge, as average age. On the right, we have the exact same function, but we've completely dropped the as keyword, leaving just a space, avgAge, average_age. By putting these side by side, we visually prove a really vital rule. Writing the as keyword and omitting it yields the exact same output. The database processes it identically. Cementing this fact really helps you read other developers' code without getting confused, though you will definitely find that including the as keyword is often preferred just for ultimate visual clarity.
So,
Tying it all together, look at what we've accomplished today with just a few key phrases. We can find top performers or senior employees using limit. We can perfectly target data and build web pagination using offsets. And we can clarify complex aggregated math using aliasing. These tools absolutely have massive real-world impacts. They are the exact foundational techniques that allow developers to tame wild datasets into clear, professional, and readable reports.
So I'll leave you with this provocative thought. Now that you've got the skills to tame your data, what complex query will you simplify with a nickname next? Thank you so much for joining me on this explainer. Get out there, open up your SQL editor, and start actively applying these newfound coding techniques to your very next project. Happy querying.